This video is about how to add basic vectors, alright? So the first thing you need to remember is that there were 5 steps. 1, 2, 3, 4, and 5. And these 5 steps will help you add any vectors together. The first step was to add the x's, and the second step was to add the y's. Now at the beginning, when we're talking about just velocity, x's and y's will be easy. There will only be one, so you don't have to do much adding. It's just there's only one there. And if there is only one there, that's fine. Just makes your job easy. Third step, redraw. And always redraw with x first. I'll explain what that means more in just a second. And then the last 2 steps are to do the Pythagorean theorem. And then the very last step is to do find theta. And theta is always equal to inverse tangent y over x. Okay? So let's start. Let's just pretend that we have this scenario here. A plane is flying this way. We'll call that east at 400 miles per hour. Or sorry, mph. That's what I meant to write down. Alright? And then there's another coming at like this, a crosswind blowing north at 50 miles per hour. So what I want you to do is to find the resultant velocity of the plane. Okay? I have an extra h there. There we go. Alright, so we start with adding x's and adding y's. Well, this is very, very simple because there's only one x and only one y. So for your velocities in the x direction, you only have 400 miles per hour. And for your velocities in the y direction, you only have 50 miles per hour. Now, you should note that they are going to the east and this one's going north. Alright, now to redraw. How do we redraw this? Well, this is the third step. So this is step 1, step 2. Step 3 was to redraw. And I said it was important to draw the x first. And the reason we draw the x first, we draw the x first here, 400 miles per hour. And then we draw the y. The tail of the y starts on the head of the x. And so that's 50 miles per hour. Okay, and the reason we do that is this makes it consistent where the angle ends up, because the hypotenuse there is the resultant velocity, and this angle here gives you the direction. If you draw the y first, it changes where that angle is. Okay, and so we always just want to redraw it like this. Okay, step 4 was to do the Pythagorean theorem. So I have 2 lines, 50 and 400, right? So the way I would do the Pythagorean theorem, if I have 400 and 50, and I'm looking for the hypotenuse, you would do 400 squared plus 50 squared equals the resultant velocity squared. Maybe. There we go. Or you could rewrite this as the square root of 400 squared plus 50 squared. And that would be equal to the resultant velocity. Alright, so if you plug all that into the calculator, you should get that equals 403 miles per hour, and that's the resultant velocity. But you're not done yet because you need a direction, and so we have to find the angle. And the angle we're trying to find is this angle right here. And the way we find that angle is always the same. It's going to be inverse tangent y over x. Okay? So, inverse tangent y over x. So we do inverse tangent 50 over 400. And if we do that, we should get an angle of 7.12, I believe. So our angle would be equal to 7.12, and this is an angle that is north of east. Okay? So we would put northeast next to that. Alright? And the last step was to write down all of this information together, these 2 bits of information. Then we did that by doing the resultant velocity equaled 403 miles per hour at 7.12 degrees north of east. Okay, and then this would be your final answer. Alright? So that should cover us for adding vectors. Alright, in the next video I will do what to do whenever you have different vectors and you're trying to find direction.